All right, so the floating point representation that I'm going to do this number, negative 92.578125. So we're going to take this and we're going to convert it to a 32-bit float. And so real quick before we start, you should remember the way that a 32-bit float is you have one bit right here that is the sign. So it is either a 0 or a 1, depending on whether or not the number is a positive or a negative. Since this number is a negative, that is going to be a 1 there, so we already know that one. And then you have the exponent, which is 1, 2, 3, 4, 5, 6, 7, 8 bits. Wait, 1, 2, 3, 4, 5, 6, 7, yeah, 8 bits. So 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6, 7, 8. I can't write really well. It's 9:30. I'm tired. And then so you have the 8, and plus this one is a 9. So then you have the mantissa, which there's going to be 23 in here. I'm not going to draw 23 lines. You get the point. So you take the 92 and you convert it to decimal. So 92 in a decimal, that is 2 complement. I'm not going to do all the steps to calculate it, but the 2 complement of 92 is 1011100. So that's the 2 complement of 92. So we have that. So now we're going to do this bit. This Sharpie is dying. So we're going to start with 0.578125. So what we're going to do is we're going to multiply it by 2, and you get 1.15625. So just taking what's here to the left of the decimal point, you get a 1. And then you subtract it, so you get 0.15625. So it's left over. So now you take this and you bring it over here, 0.15625. Multiply that by 2, and you get 0.3125. That's a 0 there, so that's a 0. So there is 0.3125. Bring that over here again, 0.3125. Multiply it by 2, and you get 0.625. Again, that's still 0, so you put a 0 there. And still carrying over here is 0.625. The 0.625 over here times 2, you get 1.25. There's a 1 there, so you get a 1 there. Subtract it out, you have a 0.25 left. 0.25 times 2, 0.5. That is a 0 there, 0.5 left. 0.5 times 2 is 1.0. So you get a 1 out, and there's 0 left. So now what you have here is 100101. So the way that you write this out with the number up here and what's past the decimal point, you are at 101110, and then point, cat here, 100101. That's hard to see. So this right here is the 92, and then this right here is what we got here. So from top to bottom, that's left to right. Now the decimal point is here, and we obviously can't have a decimal point in there, so we're going to shift it over 1, 2, 3, 4, 5, 6. So it has to move over 6 points. If we start it here, it's got to move 6 points to the left, which is where we need it. So that is meaning that the exponent, which is going to be up in here, the exponent is going to be a -6. And remember, with a -6, that is what you actually, you can do the 2 complement on it. So what you get as the final result is the sign is just 1, since it started off as a negative number. The exponent is the 2 complement of -6, which is 1, 1, 1, 1, 1, 0, 1, 0. And then you have the Mantisa, which I'm not going to write the entire thing, but it's going to be 1011100100101, which is this number just with the decimal point over here. Now, in the final version, since it's going to be 32 bits, you have to add in a whole bunch of zeros here at the beginning, basically however many you need to make this be equal to 23 total digits. Because in the 23 plus the 8 plus the 1 together will be 32 for the total 32-bit integer. So that's the final answer.